Students, very good evenings. Today we are going to discuss about common emitter amplifier experimental way. So we have to study about the frequency response of common emitter amplifier. So we have here circuit diagrams you can see on the screen. So we have to give the instruction related to how to give the supply in the virtual lab. So we have the source voltage Vs is set to 50 millivolt at 1 kilohertz frequency. So while keeping source voltage constant and vary the frequency from 50 Hz in regular steps. So next you can set source resistance Rs as 100 ohm. Then set collector resistance Rc 4000 ohm. Then set resistance Re 1000 ohm. Then set load resistance RL 2000 ohm. Then set base resistance RB1 47 kilo ohm. Then set base resistance RB2 10 kilo ohm. Next, set the coupling capacitor CC1 10 microfarad. Then set coupling capacitor CC2 10 microfarad. Then set bypass capacitor C 10 microfarad. Now what we can do, we have to click on add to table button to add the reading to the tabulations, while we have to vary each interval from frequency side as a 50-50 millivolt as intervals. Through that it will be like 50 Hz, 100 Hz, 150. Also you can vary some more frequencies. So while keeping resistance as a constant, we are varying the frequency. Then you can click for each frequency variance plot options. While plotting it, you can have the plot magnitude graph of the common emitter amplifiers with frequency along with x-axis and magnitude in dB along y-axis. So like this you can take 10 to 15 readings, then click on the plot the graph. So once it is successfully completed, so you will get the tabulation reading. So according to that you have table. So please note down it and check with frequency versus magnitude tabulations how it is varying. And each interval we are going to set the frequencies. So we are setting the frequency response here, and for each frequency we are going to click on add to table. So only we have the tabulation reading. So finally we can plot the graph based on our magnitude versus frequencies. So we are taking step by step process. So here frequency response of common emitter amplifiers, we have like transistor component BC 107, then we have various resistor, capacitors, breadboard, DC regulator, power supply. We can take 0 to 30 volt, cathode oscilloscope, 0 to 20 megahertz, function generator, 0 to 1 megahertz, connecting wires we can take as per requirements. Then we have the frequency response graph here, so you can see on the screen. So characteristics of common emitter amplifier is we have large current gain, large voltage gain, large power gain, current and voltage phase shift will be 180 degree. So moderated output resistance will be there. So you can see with this plotted graphs, please take this graph midband gain we can see, low frequency cutoff we can see, high frequency cutoff, how much we can see on the screen. If you want to calculate the bandwidth, you have to do the fH minus fL in hertz, like high frequency minus lower frequency. Thank you.